Hello, everyone, and welcome to the webinar. My name is Travis Spencer. I'm the CEO of Curity, and I'm joined by the CTO, Jakob Ideskog. And today we're going to be talking about decentralized identity and how we can use this with verifiable credentials. It's a really exciting and new topic, so it's great to have you with us to learn more about it. This is something we've been working on since last year, so it's also really great and exciting to open up and tell you more about what we've been building and how all this stuff works. To do that today, Jakob's going to be going through and showing us some theory and some information, and also giving a demonstration. And I will sort of be your quintessential audience member, Jakob, posing different questions and making sure I understand as well, and relaying questions from the audience, because this is a live webinar. So if you do have questions, shoot them out. Otherwise, I'll definitely be peppering you with questions, Jakob. So maybe you can jump us right into this, because we do have a lot to go through today.
Absolutely. Thanks, Travis.
Mm-hmm.
Yes, it's going to be a detailed webinar, I think, this time. We're going to start at the top and then go into the weeds a little bit here to get the ins and outs of this. But today we're going to start with a little bit the dilemmas around identity, just to set the picture. And then once we have that, we're going to dive into decentralized identity. What is that? And in order to understand that fully, we need to talk about things like DIDs, that I'm assuming some of you have heard about, but it's probably new to many. We're going to talk about credential issuance. We're going to talk about the wallet and wrap up a little bit with verification of these. We're also going to do a little bit of a demo in the middle here around the issuance. So let's get into it. So when I say the identity dilemma, what I mean is identity is a problem because I need to know something about you typically when interacting, but I don't always need to know who you are. In the physical world, this can be handled in different ways. For instance, if you need to know that I'm above 18, maybe you need to see my ID. But if you look at me, you're probably going to guess I'm above 18 because I'm way above. So you don't really need to do that. But with machines, we can't do that. With machines, we'll have to, present enough information that is trustworthy for it to make that decision. And that means we typically overshare. And in both worlds, both digital and the physical world, if we overshare identity data, we can lend ourselves to be hacked essentially, or impersonated. And there's a lot of risks on that. And which leads us to sort of the second dilemma around identity, and that is the privacy. If I tell you, if you need to know something about me, you don't need to know everything about me. If all you need is my age, then my address shouldn't be there, or my name perhaps doesn't need to be there. And the more we share here, the more privacy we sort of let go of, and that information can be used for different things. And identity, typically when we talk about it, especially in decentralized identity now in its early stages, we talk a lot about e-identities, like EIDs and these strong identity things. But your identity is so much more, right? It could be your university degree, it could be, your marital status, and these are issued by different authorities. And sometimes you need to mix some. Physically, if I were to prove that I'm married, for instance, I probably need to present a paper from the tax authorities here in Sweden, but I probably also need to present my ID or my driver's license, so they can be correlated and that you can know, yes, this is true and you are you. Whereas in the digital world, we don't really have this connection yet, so we're building it in various ways, and it becomes very entangled and interconnected, and a lot of data about the user is then being shared unnecessarily, because just in order to prove one little thing, I had to share all these other things with you as well. And that's what we want to get away from.
And it also not only compromises the privacy of the user, but also introduces risks to the organization who's collecting all that extra data that they probably don't need, because then they have to manage it and care for it and be a good custodian of it. So if they could lessen that, they'd also lessen the risk that they have.
Exactly. That's a good point. And it could be things like even just the log file, of things when you're logging in is problematic from that aspect. But if we step back a little bit and think about identity, physical, digital, doesn't matter. When there are pretty much always these three actors in play. We have, I named them here just to make it a more concrete example, but we have some authority, which is the issuer, in this case, the government. We have some verifier on the other end that wants to know something, the bank in this case, and we have the user in the middle. And so if the user wants to do business with the bank, it first, at least here in Northern Europe, it first needs to go to the government and get an ID issued. Could be a driver's license, could be an identity card or a passport. So that's issued to the person, and then it brings that identity directly to the bank. And the bank can verify this by knowing and touching and understanding what that piece of information looks like and feels like, and there's a picture on it, they can verify that against you. So there's an implicit trust that the bank trusts that if the identity card looks in a certain way, it's valid. And there are mechanisms on these also to check that they're valid. So that trust is, okay, if the government issued it to you and I can verify that it's yours by looking at the picture, it works. In the digital world, however, it doesn't work like this currently. We have the same three actors, but there's a direct relationship instead between the issuer and the verifier. And typically this is done by federation, but it doesn't have to be SAML or OpenID Connect. It can be custom things as well. In the Nordics, we have an EID that is used all the time. So if I were to request access to the bank and it would ask me for an EID, the way that would happen would be that it would federate or call the issuer of that EID directly using HTTP. And there an authentication process would take place and I would authenticate, and then the result would be handed back to the bank, trusting that result. And this introduces, a digital trail, first of all, because now not only the bank knows that I logged in there, but someone else knows, the issuer of that EID knows because they were called. So when I go somewhere else and do the same thing, that is also trailed. And this interconnect is not loosely coupled, it's strongly coupled. And the other problem of that is, of course, it doesn't really scale. I can't use this EID on a service that doesn't have a direct relationship with the issuer of it. So that's where we are today. And that's what decentralized identity is trying to sort of get away from and get back to the picture we had on the previous slide, where I hold something and I can present something. So let's dive into that a little bit. So we have these actors, but when we talk decentralized identity, we give them slightly different names. We still have the issuer that issues something now called a credential. And the credential is issued to a holder, and that is typically a wallet, or I would say almost always a wallet. But the term, we call it a holder. So you have it there, and then it can stay there for a very long time. It doesn't have to leave the wallet. You got it at some point. Then at a later point in time, you can present this credential to a verifier. So with the bank example, it would be the same here, that I would first go and get this credential from the government, but then I would keep it in my wallet so that at a later stage can present it to the bank. And the bank at that point wouldn't need to call the government's API to verify this. It can be done cryptographically instead.
So would you say, Jakob, that that's kind of the crux of this? Like, instead of that direct connection, now we have this sort of intermediary, the holder, where we break that connection and it's not possible to create that sort of trail of online activity. Is that the crux of everything here?
Exactly. That's the whole point of decentralized identity, that we now put the identity in the hands of the user. So you can decide when and how you share it, and the one that gave it to you will never know how that was. There's of course some sort of trust still set up here, and we'll get into that a little bit, but that trust is implicit. There's no direct connections necessarily going on. So speaking of trust, how can the verifier know that I'm the owner of the credential. If we talk about a physical credential, you know that by looking at the picture. And if the credential doesn't have a picture, you probably combine it with something that does. So you can build up that trust. So there's that. You need to know that I'm the one who should be able to present this. And then there's the other trust. How do I trust the credential itself? So those are two different problems that we need to solve. And the first problem is solved with this new technology of decentralized identity that we'll dive into more. The second problem of how do you trust the credential itself, that's kind of already solved. That's what we do with federation and all of these things. When we use it on the web all the time with PKI. If you go to a website and it's green on that checkbox, you trust that because you trust that the signatures go all the way up to the root and that those were issued in a pure way. So the same type of structure can of course exist even here, that the issuer uses PKI, for instance. It doesn't have to, but it can. But the point is you need to prove both. You need to prove that you are the one who can present it, and you need to trust the one who made the credential.
So just like a real world example of that, like you had your COVID pass, but it didn't have any sort of identity around that. So you'd put it together with like a driver's license that had that name that matched. So when you went to a restaurant or whatever, you had both of those and could say, okay, I have the pass or I have the vaccine and this really is for me. And now we're doing that in cyberspace. So the verifier is some sort of website or digital service that's able to do that same kind of thing we've been doing in real life.
And we're actually doing it even better because the way we're building up the trust here is that I don't need to present my driver's license next to the other credential. We build it into the credential itself, saying, yes, this belongs to the one who presents it because it can prove it, but it doesn't have to tell you anything more about it. So it's very, 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 very good like that.
So if it's almost like a booking a reservation credential. It's not having, it's like disjoint from COVID pass and driver's license. It's just like to have a table here, you need these things. So it makes a credential specific for that. And the verifier only sees those pieces of information.
Yeah, exactly.
Yeah, sounds really great.
And these credentials, the last point to know about these is they're bound to a subject. We say subject here in the identity world, and that is typically a person or a natural person, as we would say. But it doesn't have to be. It can be your car, it could be your dog, but it's bound to still a subject of some sort. So that subject is also tied to your wallet, which we'll get to. So we talked about these two types of trusts, the trusting in the issuer and trusting in the one who's presenting. And the issuers, I said, we kind of already solved with PKI and other things. There are many ways to solve that. The new thing is, how do we solve it for you as a person with your wallet? And that's when DIDs come in. They're called decentralized identifiers. Then it's a way to build trust without PKI, essentially. So these are globally unique identifiers. If you see the pink box here, they have this format, DID : a DID method. I'll show concrete examples here in the text, and then : a method-specific string. So if you look at the line here in the middle, it says EBSI, DID : EBSI : something gibberish. And that's what a DID looks like. And the first thing here, DID, it's just saying, okay, everything that follows here is now a DID. The second part, DID method, it tells us how do we resolve this? How do we understand this? What does this mean? And the third part is specific information to the method that we used. And the point of these is that they resolve to public keys that you control. So instead of having certs and all these things distributed with chains, I could, for instance, publish my keys on a blockchain and have this DID to prove that I am in possession of those keys. And you could know that by me presenting proof of that. So we'll dive into this even more. I know it's a lot to understand early on. Yeah.
Question on that though, like there's all these DID methods, and you list a few of them here, like ION and ION and EBSI and whatnot. How do you ensure that those are all globally unique?
So it's up to each method to make sure that the last part is globally unique and the first parts are handled by the method itself. So there's a registry of the methods that are currently available, and then each method must make it unique after that, so to speak. I'll get
So
to a little bit
the
more.
did
Yeah.
register will ensure that essentially.
Yes, exactly.
Got it.
And I mentioned the blockchain, but these aren't specific to a blockchain. It's up to the did method to say where are these keys or how are they managed and so on. So Ion, for instance, here is a Microsoft project that they launched a few years ago that's using the Bitcoin blockchain to store stuff. They also have a version of that which is self-contained, so all the information is in the DID itself. It's just a very long string of stuff. The last one here, web, that's completely blockchain agnostic. It uses instead your domain. So you can put data on your website that you control and point to that using a DID. So there are many ways to use DIDs. It doesn't have to be tied to blockchain. And I think that's a very important thing to mention here, that decentralized identity is not requiring any blockchain technologies at all. It's used with that sometimes, and it's often intermixed or confused with blockchain and these ledger technologies, but they're not needed. So let's look at the DID. What is the DID? So in the middle here, we see the DID. So we have the EBSI DID, which is the European Union are trying to standardize a way to do EIDs, and they're defining their own DID method in order for people to work with their keys. But no matter what, the DID always points to a DID document. So when I know the method EBSI, then I know how do I find this document given the string that follows. So I can look up this document, and in that document, there are public keys. So these are my keys. And I am the DID subject, and I'm the only one who has the private keys. And I can use the DID controller to update this document, so I can change the keys, but it's still mine. Only I can do that. And then I can use a DID URL if I append like a slash or a fragment, like a hash or a query string on here. Depending on the method, it tells you what am I pointing to in the document. So I can say not only this document, but I'm actually meaning key 3 here in this document. So that's a DID URL, but we're usually just talking about the DID itself. But specifically, that's this string here pointing to a DID document.
But like a simple explanation then is like a DID is like a URL that you access a website, web page on the web somewhere, and it just happens to be instead of web pages, they're public keys.
Exactly, and depending on what it says after DID : is do you go to the web? Do you go to
right.
Bitcoin blockchain? Do you go to somewhere else?
Right.
So that's up to each method, and there are many. And worth mentioning here is this is not how DIDs work. That's well understood, but there are no set standards on which DID methods should we use. There are many, and different projects use different ones. I think we'll see a conversion here in a few years where there will be a few that are popular depending on what you're doing in identity. I mean, the European work here on EBSI will probably drive EBSI for e-identities in Europe, but something else in the US, obviously, and so on. So that was a little brain dump on the DID stuff, but let's talk about the wallet now, or the holder as we call it. So the wallet is an application, and you probably all use the Apple Wallet and so on, and it's essentially something like that. It can be self-contained. It can exist on a mobile device with no cloud backing or anything like that, or it can be a website that you log into. But the point of the wallet is that it holds your private key. And that key is the thing that proves that you own this DID. You are the one who possesses that. And if it's a website, it's obviously a roaming wallet that any computer you log into, you can use that wallet. So the key is in the cloud, and there's things around that that makes it portable. But if you want, you could also use it on your phone and have an app that doesn't have a cloud backend, and you generate the key there, you publish the DID document and all of those things, and then your wallet is that. So if you lose that phone, you lose all your stuff. You can't recover it. There are, of course, drawbacks with that, but the benefit is it's completely privacy protecting, because there is nothing else that could see what you have in your wallet. Kind of brings us to that anecdote you brought up earlier, Travis, around the Bitcoin wallets. I mean, they've had this for a long time, right?
Mm-hmm.
If you lost your hard drive where you had your wallet, you lost all your Bitcoin.
Mm-hmm.
and it's the same thing here. So there's pros and cons. But the point is we want control back to the user here.
Right. And I mean, key management isn't a new thing. I mean, hardware security modules, if you lose the key on that, everything that you were signing and encrypting with those was gone. And so, if you had it on your smart card and just like you get fired, you just crack your smart card and everything that was encrypted with that key is now lost. So this idea of a cloud wallet, I've heard it called a key escrow service, because it's able to back those up and keep those. But even in the self-contained case there on the right, Jakob, are you able to back those keys up and take them out so you don't have a cloud-based escrow, but maybe your own private escrow?
I mean, yeah, sure. So completely up to the application on how to manage that. So if it's hardware control keys or software control keys or exportable or not, I mean, it doesn't matter from sort of the decentralized identities perspective or the wallet's perspective.
Right. So there's implementation detail whether or not you want to allow that.
Yeah,
And
exactly.
maybe you don't want to.
Mm-hmm.
Got it.
Right. So let's dive into the credentials then. And there are a few ways to do decentralized identity. It's been talked about for many years, and I'd say when a few years ago OpenID Foundation picked this up and started to really move with the idea and started to put standards in place here, and that also kind of triggered a lot of movement in this area because things fell into place, I would say. OpenID is a very good protocol for stitching these things together. There are other protocols that are doing this, like DIDCOM. There are versions built on top of that and so on. But what we'll talk about today is the OpenID for verifiable credentials. Note, though, that it's not OpenID Connect. So this is a new standard, OpenID 4 almost, if you will.
But just on that, because there was a question about the maturity level of this. I mean, the whole DID space, that's a lot of research, a lot of work going on in that. But like Jakob says, once the OpenID Foundation picked it up, it really did start to advance more rapidly. And it also was the advent of ledger technology and Bitcoin technology, and sort of seeing how the money is almost the same as identity in that respect. And so it has really gone from an idea of the science project or academia or peripheral research into more mainstream usage and use cases that are already now being explored.
Yeah, and the standards, they're in the works. So I think we're at implementers drafts on all of them, but early versions still. And they are changing, which is good. There's a lot of companies and people involved in this, and so new ideas keep coming and they're being fine-tuned, but they are moving targets still. So if we look back at the picture we had, we're updating the terms again a little bit here because we said holder, we said issuer, and so on. Now we're calling it a verifiable credential issuer. We're calling it a verifiable credential. And the wallet we're actually calling SIOP, self-issued OpenID provider, which we'll get to. When presenting the credential, we call it a verifiable presentation. And then we have the relying party. That's the good old word, the website or the one who wants to know something, the verifier.
And we call it this in the context of OpenID.
Exactly.
Okay.
So verifiable credentials, they contain pretty much claims about a subject. So if you think of ID tokens in OpenID Connect, they contain claims about a subject. So it's not super different from that. Like I said before, the subject is typically a person, doesn't have to be. They are issued to that subject. So that's a little different. An ID token is issued to the application, whereas the verifiable credential is issued to the subject. So the wallet, the one who holds the key for the wallet.
I think you might be kind of understating that, it's just claims about the subject in the verifiable credentials, because at Curity, I mean, we're very steeped in claims and go very deep into claims in our implementation of OpenID. I think that it just feels natural to us to use claims and talk about claims in verifiable credentials, and others are doing that as well. But I think what you'll see here in the demo shortly is that all of the same claim subsystem that we have just manifests itself now in a new packaging called a verifiable credential. But it is very much the same things we've been doing, just now in this new kind of token.
Exactly, and that's the word here. Verifiable credentials, they're tokens, just like the ID token and the access token. They're tokens with a purpose, with an audience, all these things, with a very specific way of how they're signed and so on. So
why are we here again, right? Because we're if we already have it, why are we doing this? Well, because of the decentralization, breaking that connection, that direct link between the identity provider and the consumer of that identity. So even if it's still just a token, even if it's still just claims, the whole message exchange pattern gives us ways of solving those dilemmas.
Exactly, and the double trust that this token is issued by someone to someone, and the third party, the verifier, can verify both that's the case, and that's not been possible before in a standardized way. So how do we issue these? Well, an OpenID provider that can issue verifiable credentials is what you need, and they can issue them to any client that requests them. That client then is the wallet, but in OpenID terms, it's a client that makes this call. In Curity's case, we can act as the credential issuer, among other things. So like Travis said, we extend our claim system. I'll show you that. And there's a new endpoint in the spec called the Credential Issuance endpoint that issues the actual credential. So I'm going to walk through the flow here, and then I'm going to demo it using OAuth tools, how this works. So let's assume we have a wallet that's a mobile application here, and it's acting as an OAuth client. And the first thing to know here is that there's not necessarily any previous relationship between the wallet and the issuer. So in OAuth and OpenID, we're always used to that either you pre-register yourself statically, like configure this client to exist, or you use dynamic client registration, and like there becomes a relationship before you can start getting tokens. Here, that's not the case. So they could be, but it doesn't have to be. So the wallet can be completely unknown. So I could get wallet X from the App Store, and if it speaks these protocols, it can work. So how do we get it to work? Well, then we need to tell it, you should now go and get a credential, and that's called a credential offer. So let's assume I'm on a website, on the university website, for instance, and I want to get my degree as a credential onto my phone. And I click like, get this credential. And then it says, okay, pull up your phone, and they show a QR code. That QR code will give the app or the wallet instructions on how do you get this credential now. That's what's called a credential offer. So that's the first step. It's not a required step. You can skip this if you know how to get the credential. But if you don't, you show this. So this QR code contains information that looks like this. So it's some JSON in here saying, oh, this is the issuer, the credential issuer over here, and this is the credential you're about to get. It's called the names credential. It wasn't a university, like I said. The other type here, verifiable credential, is always in there. And it says there's two ways you can get this. Either you use the authorization code flow, like we know from OAuth and OpenID, or you use this new grant type pre-authorized code, which I won't demo today, but it's available in Curity in the coming releases here.
But you probably authenticate before, like to get the name or the degree or something like that. So before seeing that QR code, you're identifying yourself through some undefined process.
Yeah, if you do that, then you can use this new flow called the
Mm,
pre-authorized code, because then you can sort of hand over that session to the phone.
mm,
I won't go into that now, but we should probably have a session on that too. But if you don't do that, if you don't pre-authenticate, then you can use the authorization code flow, and then you have to do the
because
authentication on the phone.
right, that'll
And
authenticate you there, and then you'll
yeah,
be identified and get the credential. So
right.
both ways are possible.
Exactly. And there's more
Gotcha.
ways too, but
Mm-hmm.
essentially this offer says any of these ways work. So let's assume we do the authorization flow where you now have to, the phone will start doing a code flow against this issuer. So this is just regular good old OAuth essentially, but with a very specific scope, OpenID Connect here, or use something called RAR. This scope tells us that we want to retrieve a OpenID credential, and that's pretty much all it does to begin with. And once we've gone through the entire code flow and the token endpoint response, you get an access token back. So this now can be used to retrieve credentials. But we also send some extra parameters that kind of tells us that this is a credential flow that we're about to do. So we send some nonces, or one nonce and some information about it back to the client. And nonces are one-time codes. So these are going to be used so that the wallet now can prove that I'm in possession of this DID that I'm about to tell you about. So we got a token, and now we can call the new endpoint, the credential endpoint. So we post there some information. We say, I want the names credential now that you told me I could get. And here's a proof that I'm in possession of a DID. So now you sign something using your private key, and you tell it this belongs to this DID. And now the server can verify that and see, I know how to fetch the public keys because this DID method I know. I'll get the keys, I'll verify that. Okay, yeah, you do have the private key because you did sign this. And the proof contained that nonce that we sent also. So we know it's fresh. It came now. You didn't replay it from before. Okay, we know you possess this. So now, oh, right, here we have the proof. It's actually just a jot where you say, this is the key I'm going to use. So I point to some specific key inside my DID document. Here's the nonce that we sent that we got from the token endpoint. And with this, the server will now issue the credential to you. And it is bound now to the DID that was presented. So now I, in the wallet, have a credential issued for me that only I can present because I'm the only one who has the private key that can prove that this was issued to me. And the credential itself is also signed now by the issuer here. So anyone who receives this can see, okay, yeah, this came from the government or from bank A or from the grocery store. And the one who's presenting it holds the key to whom it was issued, so I can trust that too. So now, if we think about this a little bit, what can we do with this type of thing? Well, when I got the credential, maybe I logged in super strongly with EIDs and all kinds of stuff, but the credential was just saying, I'm above 18. All it's saying, just a string greater than 18. And then when I present it later on to someone who wants to know that I'm above 18, they trust that, oh, the government says he's over 18. I have no idea who this person is, but I know it was issued to this person because it holds this private key and it says it's over 18, access granted. So you see now how we can issue things that are not privacy compromising by giving it to the wallet here that is mine, and only I can prove that I can use this later on. So the issuance step is quite important because we can take measures to authenticate you there, but we have no idea how you're going to use it later on. Where are you going to go and present this? I have no idea. It doesn't leave a trail. So very clean like that.
Yeah, it's brilliant with the proof of possession there and sending in, go and fetch my public key here, and here's a signature of the thing you challenged me with that nonce. So it ties it there and then signs it by this authority that the receiver of that's going to trust.
Exactly.
Great. Questions are pouring in. Question about Pixie. Do we need to use Pixie in that code flow?
Yes, I think you do, especially in the mobile app case. I don't remember if that's required on the spec or not, but generally you should. There are many ways. I mean, there are many details of OpenID that you can add on here, many security measures that you could add on. I mean, you could go full on FAPI here and use PAR and use all these things, or be pretty plain and do a more simpler way. So
Right, but the Pixie, that would be defending against the redirect and the code flow jumping back to some other mobile application. Whereas
exactly.
this is like, okay, whichever application you've gotten into, the right or wrong one, you're going to then call the credential endpoint with that access token and say, here is a proof of a private key over a nonce, some sort of challenge you gave me, and I'm going to, you fetch the public key and make sure it matches, and if so, burn that public key into the token. So it's almost orthogonal to Pixie. I mean, do that.
It is,
Use
yeah.
Pixie to make sure you don't get some sort of, nefarious actor jumping in there in the redirect, but it's not needed. Well, it's not the problem we're solving here.
No, exactly. Pixie was in this request here, but I didn't show all the arrows of the authorization code flow. But mobile code flow in general, you should use Pixie. But like you say, it's unrelated to the problem here with the credential.
Yep.
All right, so we got the credential out. So let's just take a look at it real quick. There's many formats of what a credential can look like, and unfortunately, this is not yet settled on where should we be. Like, which keys strengths should we use with algorithms? Which formats of JSON? How should it be wrapped? And all these kinds of things. There's a few, but there's some that are more popular than others. And I think this too will kind of come into a good standard in a while. But currently, there's two sort of main ones you should know about. There's WC3. They have a data model, and it has a few variants. It can be used as an LDP or a JOT. And the JOT one, I think, is the most popular, and that's what you're seeing here to the right. And the JOT has its outer structure, which is a regular JOT, but some things to note is that the subject, like I said before, is the DID. So the credential was issued to the DID. We don't know that it's Jacob that holds that DID. You don't have to know that. And so that's the regular JOT stuff. But then in the middle here, you have VC, and then comes the specific stuff from the data model of WC3, where it says it's a names credential and it's expiration, blah, blah. And here, credential subject, here we see the actual data, the claims around this. So given name, test, family name, testerson. So that's the claims that are in this whole package here. So there's a lot of metadata around the actual credential. But here it could say, age above 18 or above 18 true false, that type of thing. Another standard is the ISO MDoc or MSO MDoc, which is being worked on quite heavily for driver's licenses. So that looks quite different from this. And you're probably going to have to be able to support a few of these formats, depending on what kind of credentials you need to receive or issue. So in Curity, we're working on adding a bunch, essentially. But these two are the main ones, and the WC3, I think, is the one that's going to be most popular for the sort of common case, at least for issuing. So let's take a quick demo here before we go back and finish up around the presentation and how to present the credential. So Curity 8.2 is coming out on Monday, and it contains an experimental flag which enables a feature called Verifiable Credential Issuance. So with that feature on, you will see a new page on the OAuth profile, and you'll see a new endpoint type. On the endpoints page, you see the credential, OAuth Verifiable Credential endpoint. and you'll see a few more things that appear. So here I can go in and I can configure. So you should note that this is experimental, and it will remain experimental probably throughout the year, both because the spec is moving and because there's a lot of things that we're building around this. But we want you to be able to try it out and start experimenting with it on your side as well as we're doing this, and come with feedback and ideas around this. But the verifiable credentials, here we can define things like the issuer, like, because it's a different issuer from the OpenID, and this is the issuer name. This is not OpenID Connect, like I said before. So there's a different metadata document that describes which credentials exist on the server, all of that. It's separate from the OpenID Connect one. In there, you will see the credentials, and here you can define them. So I can create the credential here, and I can say it's going to be HTTPS. You typically have some sort of credential schema that you're following. There's many, or you invent your own something, and you call it, this is my credential. And you can also define what scopes is needed for this credentials and what claims should be issued when this credential is requested. So maybe this one actually just gives you the birth date of the person when you want this one, for instance.
If you had such a type there, Jakob, could you, and you had birthday, could you, after issuing that, could you derive then the greater than 18, so you actually know the specific birth date in the issued credential, but then don't reveal the birthday to when you present it, and instead derive a zero knowledge proof to say that greater than 18? Or does the actual issuer need to remain, keep that proof anonymous to begin with?
Good question. So you can derive that. So I could, in our claims system, and this is the beauty now. So we have the credential type here, names, credentials, for instance, and it picks up a few claims. So I could go here to the claims and the designer that we have, because these are the claims that gets picked into the credential. So I can make one, or I could change one. I could say that the birth date one is picked up from the account. So we get the birth date, and then I could add a transformation to it where I could calculate just based on that date, is it bigger or less than 18 years, and then return a Boolean, true or false, as the actual value. And of course, I probably shouldn't name it birth date, but something like that. And what's new also in Curity 8.2 is you can have reference claims. So I can have the birth date claim here, but I could create a new one called older than. And I can say this is actually a reference claim. So it references the birth date, and then it does the transformation here saying, if this is blah, blah, older than, and then, so I don't, this is not picking up new information, it's picking it from the other claim, and then transforming it and naming it as a different claim. So I don't have to read the same value twice from the data sources and stuff like that. So there's some new goodies around that. And then on the new verifiable credentials, that's the claim I should use, the older than claim here instead.
And are those reference claims, are those only usable with verifiable credentials, or is that a general feature?
It's a general feature. So anything on the scopes claims page is general. You can use that in OpenID tokens or anything. So this is just reusing all the nice things we had, and it's just coming together nicely now with verifiable credentials. It's essentially just a new layer on top here. So we have the type, and then, like I said, we need to now know, okay, which format should this be? So the names credential is just the sort of the 3 lines in the middle, like the first name, the last name, and that. But what's the rest going to look like? Well, that's called a verifiable credential template. And here we define the things around the template, what it looks like. It should probably have a logo, because in the mobile device later on, when you see all these claim or credentials, if you think of, any wallet you've seen, is like, this is an airplane ticket. This is you want stuff to help the UI to show what this is, and this is metadata information that can be published. And here I pick the type. So when this type is requested in a certain format, this template is used to issue it. And how are we going to issue it? Well, there's a new type of token issuer that can issue credentials and sign them in the right way. So that's the one you should use. And there's a lot of stuff here that you can pick around. What DIDs do we accept from the wallet? Any, or just the EBSI one, or just the ION one, or whichever. So this template is used to sort of narrow down, this is how we're going to shape the token. So it's like another layer on top of the regular token issuance that you're used to. But that said, you can still add a token procedure. So you can still go to the endpoint, and you can still, if we look at the credential here, you can still test it and change like you're used to. Oops. Previously. It just looks a little bit different because there's more. You work with the inner data of the credential, and then you use that inner data to create the sort of template, call the template, and get the outer data of the credential, and then you can modify that, and then you issue it. So it's a little different, but we tried to be good on our docs here, and there's a lot of tutorials and things in the works. So you'll be finding information soon. So that was the how to set it up. So let's look at how it works. So in OAuth tools, there's also an update coming with the new flow called VCI, Verifiable Credential Issuance. So I mentioned before that we have the credential offer first, where you tell the client or the wallet, how do I issue something? That's not needed. If you already know how to get the credential, you can just start. And in OAuth tools, we don't need the offer, obviously, because this is a flow tool. So I'm going to start off by just doing a code flow, requesting the OpenID credential scope. And that just looks like a regular code flow with the scopes. Logging in here. And now I got an access token. If we look at that access token, it's a regular token, nothing special in that. It has the scope OpenID credential in there that we wanted. And now we go to this new flow, which is we're going to call the credential endpoint now using this access token, and we need to put together this proof that we have a DID. So what tools can help you with that? So I use this token that I got. I want to request a WC3 version, which is this string here, and I want the names credential type. And on the code flow, there's a lot of details here, so mind that. But you can look at this again later and see it slower, perhaps. But there's a nonce that we got, so I'm going to use that, stick it into the proof. And here I've prepared a DID, and this is my wallet DID now, and it has a public key and it has a private key. So I'm telling, I am in possession of the private key, so I can sign a proof now. So we'll make the request to the credential endpoint, and back we got the credential. And the credential is a JOT in this case. And as you can see, like I mentioned before, the subject here is us. So this is the DID, that's the subject of this credential. So depending on how we authenticate it and all of these things, the issuer knows or more or less about us. But the point is, whoever we present this to later on will not be able to say that, well, now it's the names, so it says Barbara Jensen here. But if there was age, they wouldn't know that this is Jacob, because nothing in here would say that this is Jacob. But it would say you can trust this because the one who presents this is correct.
So a couple questions though. So now this credential will be issued to the wallet, and the wallet will store that and present to various places. So what if you change your private key and the public key on the DID has to also match? Do I have to reissue this credential into the wallet? Can I stop do I have to stop using it, or how does rolling keys work?
You can have multiple keys in your DID document,
Mm,
but if you lose control over your DID, then you're done. Then you
okay.
can't present these anymore.
So
You need
there's
to
a
maintain
list of
control.
public ones there, and
Mm,
if I have a new private key, I'm going to put the new corresponding public one on the DID, because here you said some fragment, and I notice in the subject it doesn't have the some fragment. So
right, exactly. So
I'll
you
just
could
start to
have
use my new
multiple.
public key saying go and use that one.
Yeah, exactly.
But as long as I still have the old private one, I can still use that when presenting the credential. But if it expires or if I don't have it anymore, then I got to go and find it in the hard drive in the landfill and get it
Right,
back.
right. So
Okay.
as long as you have a way to update your DID document with the current keys that you have,
Mm,
you're fine. But if you
okay.
lose that way, you're not fine.
Okay.
Then you have to go and dig up that hard drive,
Okay.
wherever that ended up. Because the issuer, or whenever you use this, you need to prove possession of this DID.
Of the DID, any
Mm.
key on that DID. So as long as I can put a new one on the DID, I'm good.
Mm-hmm.
Okay.
Should depend on the DID, I guess, but these ones that can contain multiple
Right.
should work
Because
fine.
in the proof, the thing that's in this proof is not the specific key, it's the DID.
Yeah, exactly.
That makes sense.
So it's issued to the DID.
Okay, new question. So we got given name, we got family name here, and we saw how we could change that in the issuer in Curity, with the you were talking about reference claims and whatnot.
Mm.
But
Mm.
suppose I want to transform this in the wallet to initials, BJ. So just say like, okay, I'm going to provide only my initials because that's all I have to do. Is that possible to derive that here on the client on the wallet, or does that have to come from the issuer?
That I don't think you can do in the wallet. No, I think that
Right.
has
So
to come from the
if you
which is the
derive
same
that,
essentially as the age thing, where you
mhm.
had to do that on the issuance step in order to do that.
If you did it in the wallet, the credential would be from the wallet.
Mm-hmm.
So if
And
your wallet is trustworthy to the one you're presenting it with, then it would work. But if it's not trusted by the one you're presenting the credential to, then you can't create that derived proof.
no, because you couldn't prove that you would sort of mess up the original credential, so the signature wouldn't match anymore. So
No,
you couldn't
exactly.
really prove that it came from there to
Mm,
begin with.
yep. Great.
Yeah. So let's go back a little bit. We have a lot to say, but we're getting to the end here. But I wanted to say a few things around verification also, which is called verifiable presentation. This is not yet available in the product, and we're working on this now, and it will come later this year, alongside with libraries that you can use to build wallets as well, and we'll probably provide some demo wallets as well. So we're zooming in on this side now. So I have the credential in my wallet, and I want to present it to someone. This is probably going to be the most common case. Some of you are going to issue credentials. Some of you are going to issue them and verify them on your own, and some of them are just going to verify. And a lot of companies are going to need to verify, I think. And this brings up a very interesting technology, which is called a self-issued OP. So before, when we got the credential, we were just an OAuth client doing something, and then we were just an API caller calling the API, getting the credential. But now the whole mobile app or the web app is becoming an OpenID Connect provider. So we're kind of shifting and flipping it backwards. So the relying party, in order to get a credential, same thing, it probably shows a QR code to trigger something on the wallet, but what it triggers is a code flow. So this, or not really a code flow, but similar to one. So this QR code contains an authorized call, and this wallet has an OpenID provider that understands, aha, here's an authorized code. What should I do? And then there are some new things in here saying, we need a credential that contains the names. It should be of this type. It should contain this value and this value and this value. It's called a presentation definition that you send in. And then the wallet looks through all the credentials it has in its store and picks ones and says, this one matches. And then it asks the user, do you want to present this back? And if the user says yes, it will post that credential back to the relying party. And it does that by creating something called a VP token. So this is all the new token. So it takes the credential and wraps it in a bigger token and signs that again with its private DID so that it can prove I still have possession of this key that proves that I'm the one who should have this credential and I'm the one who should be able to present it to you. And there's a lot of details in this flow, and I won't go into that right now so much, but this part of building the wallet will be a bit complicated. And at Curity, we're working on providing libraries and building libraries that you can use if you want to build your own wallets. It's still a lot of greenfield in where is this going to be used. I mean, the use cases are endless. You could have coupons in your store. You could have, anything that is not necessarily strong identity stuff. So you might want to build in wallet technologies into your already existing apps, or you want to build, or use someone else's third-party existing pure wallet. But both cases are probably going to be very relevant in the coming years here when this is used. And of course, this is one way of presenting a credential, but once you have the credential, you could use others. You could use NFC to present it to, a bus where you're going onto the bus and it presents that, yes, this is a ticket I have, or so on. So, but the OpenID way of doing this right now, which is still evolving, is around the self-issued OP here. But super important, when we did this presentation, there was only 2 parties involved, only the RP or the site you're accessing and the wallet, nothing else, no other call going out to anyone else. So as long as you can trust the chain up of the credential, you're fine. They never need to know that you got it. More practically though, it looks like a lot of stuff to build into your website in order to just verify a credential. So it will probably look more like this, that the app or the website that needs the credential calls Curity with a regular code flow saying, hey, I need this claim, I need age. And Curity translates that into, we need to request this credential, and does this flow against the wallet, gets the credential back, sticks it into the ID token back to the website or the app that needed it. And all you do is check the ID token. It's like, oh, yeah, here we go, H, fine. So you trust it the same way as before. So we're gonna sort of remove that complexity from the sites, just like we normally do with authentication. Right. That brings us to the end. That was a bit quicker there on the verification. I think we'll have a whole webinar on that before long, because there's a lot to be said around that as well. But I encourage you to download 8.2 once it's out and enable that feature flag so you get these features and try it out a little bit. There's no special license needing for that, so any license will allow that to be worked with in the experimental mode. But if you take away a few things from this, it's remember the 3 actors, the issuer, holder, and verifier. It's not more complicated than that. The wallet is actually an OpenID provider. So it's doing a lot of stuff in there, especially when presenting. The issuer is just a OAuth server, but with all of this OpenID verifiable credential issuance on top of it. So it's built on OAuth as the others, but with a lot of capabilities on top. The verifiable credentials is a token that has claims that can be verified that the one who presents it can do it and who it came from originally, who issued it. And it can be presented to the verifier. Anything more to add there, Travis?
A question that came in on the previous slide. So like, how does this relate to things like passkeys? And I think that, again, they're orthogonal. So it's like, if you have that self-issued OP and you want to say that you're 18 years old and you want to assert that yourself, how would you do the login in the PSYOP? You might click the little passkey thingy on your phone. So the authentication part in PSYOP is disjoint then from the actual claims being issued in that, right?
Yeah, that's correct. So you probably, when you issue a credential, you probably have an account with the issuer. That would be normal, I think. Not necessary, but normal. So you log into the issuer and say, I want my university degree now because I'm a student. I was a student here, so I have an account and can log in here. Passkeys was perhaps the way you logged in to do that. And then you click, now show the QR code, the offer, so that I can pull up my wallet and scan that and get the credential. And then you can transfer that session up to the phone and pull the credential up there. So yes, they're very orthogonal. But a credential, when you're presenting that is a form of authentication, right? So when somebody presents a credential to you later on, that's perhaps all you need to log that user in. All you needed to know was that they were above 18. You don't need to know more at that point. So you could use that as the authentication mechanism. Just, give us this and we're fine, you're logged in. Or you need other things. So presentation is a form of authentication, you could say.
And just in this picture, I mean, the intention here isn't that Curity just be some sort of pass-through, right? Like it could augment the actual ID token or the access token that's coming back. So if you're doing a bunch of API calls and they need more data, I mean, you might go to the PSYOP and maybe you use passkeys and you get that stable identifier, and then from within Curity you can start to look up other stuff and say, okay, this is always the same user ID, so let's give them their subscriptions and give them the services that they've paid for, and all of that other data that you've collected within that application, provide it into that, right? So
Exactly.
Curity isn't just necessarily passing through, it could be enriching.
Yes, for sure. So like I said, there's a lot to be said on this topic. It's a deep one.
Definitely. Other questions? Does the flow always start with a QR code? I think you mentioned that it doesn't, but can you clarify that?
Yes. So no, it definitely doesn't. It could start with a redirect because it could be the wallet is in the browser, so you just redirect to the wallet and back. It could start with just from the wallet, that the wallet knows how to contact the issuer already and can start on its own doing that. And you log in and perhaps it pops up a browser and you log in or however. So the QR code is not at all required, and it's just a good probably the prominent way when you have a device like a phone and a computer where you're logging in on the web. But definitely there will be other ways, and in some cases there could be other technologies like NFC and whatnot.
Great. Anything to say about what's coming up? You said it's experimental. Can you say
so
anything?
The experimental release is coming now on Monday with what I showed you essentially. All what tools will be updated in the same time frame with these things. Bunch of tutorials and how-tos are in the works that will come also in the near term here for this. And then in the consecutive releases now, there will be updates both to the issuance. We'll add RAR support, which is a different way. Instead of using scopes, you can be more specific and say more details on what claim you want exactly or credential. And then there will come presentation support later this year alongside with wallet support for mobile and web.
So the iOS and Android SDKs will be updated to also be able to make mobile wallets.
Yes, exactly.
Wow,
exactly.
That's going to be sweet. Exciting. So how should people funnel their feedback to you and the team?
Can definitely email us info@Curity. We're also active on Stack Overflow questions. If you tag Curity, we usually find those and can discuss there if they're more like programmer or developer type questions.
I notice you're also on Twitter, and then you're at the various IIW and identity shows.
Exactly.
Great.
Very nice.
Well, thank you.
Thank you.
All right. Have a good one.
Bye.